Okay, I'm going to try and get through this paper quickly because it's a long paper and I want to try and do it in under 10 minutes. So, Carl's an athlete, blah, blah, blah. He needs respiration for his muscles. So, describe the process. So, respiration is oxygen plus glucose. We take in oxygen from the air, glucose from our food, and it gives us energy, and we release carbon dioxide and water is by there. So, muscles need oxygen for a second mark. Use the words to describe from the box to complete the equation. Well, I've put it there. So, glucose plus oxygen, carbon dioxide plus water, and then plus energy. So, you can either put energy above the arrow or at the end there. During the sprint, Carl's breathing rate and pulse rate increases. Write down 2 reasons. I think I've given us good 2 there. So more oxygen is needed for the muscles. Heart rate needs to increase because it needs to get that blood around to the body, to these muscles. So the blood contains oxygen, so that's why his heart rate increases, to increase that blood flow. The figure shows someone running on a treadmill. The ache was caused by high concentration of lactic acid. The equation is glucose. There's no oxygen, so this is anaerobic respiration. Anaerobic respiration is where there's no oxygen available, well, not enough oxygen available, and then you release that lactic acid as a waste product, which can be painful if it builds up. The investigation here: how much more lactic acid was there in the athlete's blood when he ran at 14 kilometers per hour? Well, you just go up there. So that is 6.8 I've put there, minus the 2.4 that was at 8 kilometers an hour, because that's what he was running. But there, look. So you're just comparing. So I said 4.4. The units are already given to us. Why is more lactic acid made in muscles when running at 14? Because I've said running fast requires energy from muscles. There might not be enough oxygen from anaerobic respiration. Therefore, anaerobic respiration produces lactic acid. That's your 3 marks there. And the next one, in respiration, energy is released in the form of ATP. Now, I've underlined that because it becomes quite important down by here. It's asking you to compare the table and explain any differences in terms of energy. Well, molecules of ATP, it says there ATP is pretty much energy. So if our aerobic respiration has 22 molecules of ATP, then an anaerobic only has 2 molecules. Aerobic respiration is going to have far more energy. So I said during aerobic respiration, there are far more molecules of ATP produced compared to anaerobic. Since ATP is energy, and it says that there, we produce far more energy during aerobic respiration. Then you've got the bell jar model. The model below represents the human respiratory system. Different parts of the models represent different parts. So it wants to know what the flexible rubber sheet does. It's the diaphragm. It moves down. It will increase, and it will say down here, explain why the balloons inflate. Well, the volume inside the glass increases, so if you pull this down, it'll increase. The pressure on the balloons therefore decrease and allows that air to come in from the outside, so these will inflate then. During breathing, oxygen moves from the blood, so it's going to move from an area of high concentration to an area of low concentration, diffusion. That's your bread and butter. We should know that off by heart. And this is frozen. Ah, right, it's gone there. Okay. Now we've got the alveoli and the last, so where the gas exchange. So to label this, the bit before the alveoli, or the alveoli, is the bronchiolus, not the bronchus. The bronchus is up here somewhere, a thicker tube. Name the process by which blood between alveoli and blood. It's called diffusion, because you get the gas diffusion. Explain 2 ways, in which the alveoli are efficient at performing this process. So large, always take the punt with large surface area. Anyway, when they're asking you how something's adapted or how it is good at its job, large surface area to maximize diffusion of gas. Lots of surface in contact with the blood there because it's got a large surface area. It's only 1 cell thick, so it's really thin. That decreases the passage of gas exchange, so it's not hard for it to get across. And then I've put a moist line in, and all you need to know about that is that gas dissolves when it's moist, so it's soluble, really. Look, no bubbles, brilliant. And then it's a little bit of reading to do on this one. So if you've attempted this question, you would have had a look. Basically, for 2 marks there, you've got to give the percentage of oxygen in the air before we breathe it, and then there's 16 after. Carbon dioxide the same, and then we breathe out 4. Nitrogen, there should be no change. And then it says, use the table to state why it's possible for the diver to use a rebreather. Well, a rebreather means that you can use this oxygen again. We only use 5%, so 21 minus 16 is 5. So we can use this oxygen that's been expired, that's been breathed out again and again. Well, at least another 3 times, because there's 16% left. So you can use that another 3 times there. How are we doing? 5 minutes. Okay. This one is unlikely to come up because I think this is for another spec, but sodium hydroxide is the answer to that. And then it brings us to this question, which we do need to know the gas test for this. So what results? So what you've got here, let me explain this one. You've got expired air in both, so it's the same air going, so it's going to contain carbon dioxide, but you've got a tank containing these glass beads, and you've got a tank containing carbon dioxide absorbers, so it's going to absorb that carbon dioxide. So what you're going to get for the test for carbon dioxide, we use clear lime water, and if there's carbon dioxide present, it goes cloudy. So this one is going to be less cloudy than this one, because that's just filling in the volume. That is just the control there. So the carbon dioxide is coming down and it's going straight into this tube. This is going to be cloudier than this one because you've got that stuff, that carbon monoxide absorber. So it's going to take some of the carbon dioxide, some of that poisonous gas out. So I've said, tube A, clear lime water, it's going to turn slightly cloudy because there's going to be some carbon dioxide going in there. But in tube B, it's going to be clear. The clear lime water is going to turn cloudy because there's carbon dioxide present. Apart from not producing any bubbles, just one other advantage for a diver and a rebreather. Well, the advantage there is that you can stay under, or she can stay underwater longer. I'm going to rush through this because I can see we're on 7 minutes. So the main, let me zoom in because you can't see that. Name 2 other chemicals in cigarette smoke that would have negative effects. So I've got carbon monoxide, nicotine, or tar. They're all going to have a negative effect on smoking, on you from smoking. And then it wants to know the relationship between these. Now this one, you can see that they're kind of the same shape. What's happening is the cigarette smoke person, which is this one, hang on, it's frozen. About 18 years later, then people start developing lung cancer. Now this isn't a direct, I mean, this doesn't show for sure, but it's a good correlation. It's a good correlation that people smoke. The trend shows that the people who smoke are likely to get lung cancer there, or death from lung cancer. So I said there's a direct correlation. There's the same shape between cigarette smokers and lung cancer deaths. And I've said for that second mark, there's a delay of around 18 years there. So it gives, that 18 years that 18 years on, if you're a smoker, you're likely to develop lung cancer there. And then the link, but there says, all right, which year were they made aware that of this link? Well, I've said, if you look at here, it starts to dip, and it starts to dip here. So I've said around about 1944 or 42, I don't know. The scales are, 1950 is around there. It could be 1945. I'm sure the mark scheme will allow some tolerance there. The graph shows some data from smoking and tobacco in the UK. So this again, if you're good at graphs, then you should be able to calculate this pretty easy. Calculate the decrease in percentage of females who smoked tobacco in 1990 and 2010. So just draw a line up. 2010 was 20. In 1990 was around 30. So 30 minus 20 is 10% change, or decrease. Suggest 2 reasons why smoking tobacco has decreased. Well, they've gone up, way up in price. There's anti-smoking advertising. So if you not that you would buy a pack of cigarettes, but on these cigarettes now contain warnings and pictures of dreadful things that can happen to you if you smoke. And they've also increased the age that you can buy cigarettes, so age restrictions there. Complete the sentence by putting the cross. The main addictive substance in tobacco is going to be that nicotine. And then the last page, and on 9:53, so hopefully this can go up in one video. Explain why smoking tobacco can cause lung cancer. I've said it can damage the cells that line the lungs. Therefore, it can cause the cells to act abnormally. So these mutations. So smoking is a carcinogen. It's only worth 2 marks, but that's your answer for that. And explain why people who smoke tobacco may find it difficult to exercise. I've said because they've got damaged lungs, they're not efficient at gas exchange. Remember at the alveoli question? So that's going to be, they're going to be damaged. The gas exchange isn't going to be the best. So there's going to be a lack of oxygen for the muscles. Yeah, that oxygen getting round the body is not going to be as much as if you was in the smoker. And that is that. 10 minutes 35.